All set and ready to, so we got, let's get started.
Okay, great. Well, again, welcome everyone. We appreciate your willingness to join us this afternoon. We're extremely excited about the progress that we've made across the board, but particularly, I think, in regard to the methodological improvements and changes that have been implemented. We're very excited about the Delphi. And so with that, let me show you a quick agenda. We have 5 items here. First of all, we want to give you an overview of some of the Delphi results. Then talk a little bit about how we're going to use these Delphi results, and that will be in the weighting of the various measures, subdomains, and domains. Third, the imputation, that is how we are handling missing data. Fourth, the confidence intervals. We're going to show you a little bit about how talk a little bit about how we're going to approach that currently and in the future. And then finally, we want to get on your calendar the proposed plans right now to have an in-person meeting of both this work group and the model design work group in July in Santa Monica at RAND. So with that, let's talk a little bit about the Delphi results. Well, it looks like I jumped ahead here a few slides. Okay, overview of the Delphi process. So welcome, Tom. I just looked at the screen. I see that our NAC chair, Tom Inglesby, is on the line. And
thanks, Michael.
We have at least one other NAC member, Bob Burhans. Welcome, Bob. And there may be other folks on the line who I'm not aware of. So overview of the Delphi process. So as many of you already know, because probably everybody who's on this line was involved in this process, at a minimum you were getting emails from me. But bear with me and let me just go over this to replow some of this ground. There were separate assessments or panels that were convened for each of the 6 domains in the original index. There was a 7th domain that was also included that was referred to as pre-event community status. And there were really kind of 2 ways that we did this. The first one was the item measure assessment. And so the assessors were asked to indicate how important each measure was with respect to its domain on importance. And then what we presented assessors with was a visual analog scale that ranged from 0 to 10, asking them to really indicate how important that particular measure was to that subdomain. And we did that 3 times. We gathered those results from the first assessment, compiled them. Dominique created histograms, and then we sent those back out to folks so that they could see what the results were from the first round, and we asked them to consider those results when making the second assessment. And then we did that for a 3rd time as well. So there were 3 waves used for each panel. Now the subdomain and domain assessments were a little bit different. Of course, they were similar in the sense that we were presenting them with the same kind of information and following the same basic principles, but we didn't use a visual analog scale. Instead, we asked the assessors to imagine that they had 100 points and they had to distribute those 100 points among the various subdomains or domains. And there were 2 rounds to that assessment. This chart, and if you're not on the Adobe Connect, I'm showing a bar chart that shows the coefficient of variation score. That is to say, how much variation was there among each of the assessors for each item measure in the final round. And of the roughly 250 item measures in total, there was only a lack of convergence on 5 of them. That is to say that the variation around the scores that were given was such that the discrimination coefficient of variation was greater than 0.5. Anything below 0.5 is viewed as within an acceptable range of convergence, and in fact the average was 0.18. So there was really good convergence, and now the chart that I'm showing now shows the distribution of the Delphi scores or the Delphi weights, and this is all of the measures. This is all the roughly 250 or so item measures that were presented. On that 10-point scale, the average score was 7.78. Well, it's rounded to 7.8. There were the modal response was 10. So, and as you can see, that it's top heavy. It's 8, 9, and 10 were the most common scores, 10 being the most common. But the NAC met, of course, this Delphi got launched in early October. I think, I don't remember the exact date, but it was right around the time, just before our National Advisory Committee was meeting, which they met on October 23rd in Princeton to talk about the fate of some of these measures. And we'll talk about some of this next week. We actually have a model design work group meeting, and I'll be sending emails out to folks about that. Typically, I put that information on the final slide of this work group presentation, and I just realized I neglected to do that, so I apologize. But we'll be talking about some of these model design issues next Tuesday at 1 o'clock Eastern Time. Now, as I say, this chart, I'm going to go back, is all the measures, but the NAC met and some decisions were made on which measures to keep, which ones to kind of jettison or at least to hold in reserve until a future date. And so if we see a little bit of a different distribution here. The average score goes up just slightly to 8.0, and now the modal score is 9, followed by 8, and then 10, 7, 6. Any questions? Okay, great, thank you. There's also a chat box here. If you're online, if you want to type something in there. We are recording too, by the way, this presentation, so it'll be available for replay, rebroadcast. We'll send that out to folks probably tomorrow at the latest Friday. So as you know, the whole purpose of this exercise was to use the input to construct weights. The way that the index is put together right now, there's no explicit weighting of individual measures or subdomains or domains, but because of the way that the index is constructed, there's fairly significant implicit weighting that's taking place, and we want it to be more purposeful in how individual measures and subdomains and domains were treated or weighted within the index. And so we're using these Delphi results to do that. As you know, we were asking you to assess the importance of all of these things with respect to preparedness. And there were a lot of detailed instructions that went into that. But in a very simplified way of thinking about it, that's essentially what we were asking about. And we derive weights from these expert assessments. This slide shows only for the measures that are the currently in the 2016 index, or proposed to be in the 2016 index, and for which there is an analogous or similar, the same measure in 2014 we see on this chart. So in some cases, there might be, there were a few measures that were added in 2016, but they were not in 2014. And so they're not presented on this because there's nothing to compare it to. You'll see everything here in some subsequent slides, but this only compares the difference between the 2014 and the 2016 index for those for which there are measures that are available in both. And you can see that there are some big differences. I would say, and most of this is a reflection of the Delphi input. Now this is illustrating the all of the measures that were included in the 2014 index, all of the measures that are likely to be included in the 26 index, and the distribution of the weights. Now, everything is normalized so that when you add up all of the weights, they equal 1 or they equal 100. Okay. In this case, it's been normalized so that all of the weights would equal 100. And so the y-axis is showing you what's the relative weight of each measure. So the highest red bar is at 6.6%, and so it is the one with the most weight. Toward the origin of that that chart, close to 0, you see that the least influential item measure with respect to the total index value, it's about 0.18, 0.2. That's the red or the maroon bars. The blue bars illustrate the relative weight of the of each of the item measures in the 2014 index. And the reason that you see this kind of, for the 2014, stair-stepping pattern is purely a function of the fact that there were no differential weights for item measures. That any item measure's weight was a function of which subdomain it was placed. And so if it was in a subdomain with 10 other measures, then its influences, they're each 1/10. And if it's in a domain that only has two subdomains, then it gets more weight than if it's in a domain that has 5 subdomains. And so that's why you see this evening, this stair-step pattern in the blue bars. Now this chart is a scatter plot, and like the first bar chart I showed you, this includes only those measures that are included in both the 2014 and 2016 indexes. So it won't include 2014 measures that are not being included in 2016, and it will not include 2016 measures that are being added this time for the first time. That is to say, they were not in the 2014 index. And as you can see that, there's some big differences here for a few measures. The one measure all the way to the right is the biggest difference. On the 2014 index, its weight was this index. And so this measure is the percent of households with who have broadband or that have broadband in the home. Some of these other dots, if you will, are things like right around, let's see, I guess I can point with my pointer here. This is whether the state level health department is accredited by the accrediting agency that accredits health departments. We have a series of other measures. Now the reason, we're still, and you should know this as analytic methodology work group members, the reason that this measure is so important is really for two reasons, I think. A, the Delphi assessors deemed it to be important, but in the current structure of the model, it is the only measure in its subdomain. And so it has more weight as a result of that. So we're not completely away from the this influence that a number of measures in a subdomain exercises influence over an index score. And this may be something that the work groups want to think about and address as we move forward. There's really nothing that we can do about it for the 2016 index, but it's something that you should be aware of. These two measures here are also the only two measures in the subdomain, and likewise these as well. But on balance, this is very powerful information that we've gathered from many of you, and for that we are truly grateful. It's a much more rigorous and purposeful approach for calculating the relative importance of these various item measures as well as the subdomains and the domains. With that, let me pause and see if there are any questions, or ask Lynn if there's anything that he wants to add.
No, Mike, I thought you did a great job of summarizing the Delphi weighting process to date. So I think we would love to hear any further questions or comments or ideas that folks have after kind of seeing these results in a little more detail and anticipating how we're going to be using them for weighting.
Okay, wonderful. Thank you. I see a question from Jim. Since the mode went down, does that indicate that items rated high were removed or placed on hold? And then Bob asked, have we summarized the reasons for excluding measures that were highly important, scored 9 or 10? Okay, so what Jim, is that Jim Blumenstock?
Jim Craig.
Jim Craig. Okay, hi Jim.
Hey, guy.
So this is what they're referring to. Here are all measures, and you can see that we're rated very high on 8, 9, and 10. Or that is to say that there are a lot of measures that were rated 8, 9, or 10. And here are measures that are currently in the index, but you can see that there are fewer 10s. I think we're in the process now of working with the communication teams and work groups and consultants that RWJF has hired to communicate these results. And so the short answer, Bob and Jim, is that we have not crafted any kind of message to indicate you know, what the implications or what the if we summarize the reasons for excluding these measures, you know, we have, I guess we're in the process of doing that. The one thing that I would say is that, you know, this really goes back to some of the conversations that we really have been having since about last March, I think was our in-person meeting in Washington, D.C., when we did a series of analyses looking at the item to scale associations, and as well as analysis that looked at how well measures hang together or correlated within a given index. And so, you know, so just to kind of replow some of that ground, but not too much, you know, there's a lot of redundancy. There were a lot of measures that were accounting for the same variation in the index that were highly correlated with each other. That is to say, they were measuring the same things. And so, you know, it's the case that a lot of those were, you know, very good measures, which is why that they were chosen for substantive reasons. But then after looking at them from a statistical perspective, you see that they were probably highly correlated with other really good measures. And so I think that's what accounts for the drop-off in the high number of number 10s. Glenn, would you add anything to that?
Only other thing to add is that I think the majority of measures that again are being dropped from the next version of the index, but that receive pretty high ratings of importance, are measures that were dropping because of lack of updated data within a 3-year time frame. That's again a criterion we applied pretty strongly to this next version of the index because we want this index to be able to support comparisons over time. And so measures for which data were not available at multiple points in time, and measures that did not have fairly recent data in at least data available for at least a 3-year window, those were reasons for you know, for dropping the measure. So there are certainly a number of measures that fall into that criteria that we know are conceptually important to preparedness capabilities, but we're not able to measure them timely enough, and we're not able to measure them frequently enough to make them useful in an index like this one that's designed to track, you know, in part track progress with capabilities over time.
Well, and also, I guess, you know, now that you mentioned that, Glenn, you know, there were also, you know, about I think about 11 other measures that are in this you know, foundational category that I think that where there was no variation. That is to say, from a statistical measure, from a statistical standpoint, they're not variables. They didn't necessarily perform well. In fact, they didn't perform at all in the statistical analyses because they don't vary. Every state, for example, participates in the behavioral risk factor surveillance system. And so that was one of the measures, and there were about 11 of those. And I think when the NAC looked at those, they agreed that it made sense to not include them in the index, but in an effort to not send the wrong signal that they were no longer important, that while maybe they won't be included for computational purposes, they will be included in a different category, and they'll be referred to as foundational measures, so that we can still, you know, showcase them as important, but they're not included in the actual computation. And so it's quite likely that there were some of those as well that were ranked very high by the assessors. Yes, this is very important, but they were not included in the computational portion of the index. Okay, any more questions?
That was in the chat box. I do think it's going to be really important to have a place in on the website or in the materials that explains in plain language why particular measures were excluded. I know in many cases it was old data, and that's a very compelling reason to me. So I'm glad that we're not including those since it's more than 3 years old. There were some where it was, after some discussion, the measure really wasn't doing what we initially thought it was, or there was some subsequent analysis where the measure wasn't as strong as we believed it was originally. I do think those are going to be more compelling reasons and will be more explanatory than for us to kind of discuss the statistical or the performance characteristics of the measures, because the community that's using this for the most part really doesn't spend a lot of time using that language. So I know this isn't really a discussion about the communication and stakeholder side, but I do think it's going to be important to really explain in plain language why the measures were excluded as much as we can.
Yeah, those are great points, Tom, and we'll definitely work to make sure we've got those issues well documented in the measure details and in other communication pieces on the index website.
Great.
Thank you. So the next item on the agenda is the imputation strategy. We just to remind you the way that the missing data were imputed or being imputed in the current version of the index, the 2014 version that's on the website, is that if, let's say for example, you're in a subdomain and there are 5 measures for all the states, and for one state, let's say Kentucky, there's missing data for one of the 5 measures. The way that score would be estimated or imputed, or that item data value, would be that we were taking the percentage of each of the 4 data items that we did have as a percentage of the maximum for the highest state. And so if Kentucky on average had a score for the other 4 items that was equal to about half of the best performing state, then the imputed value would be estimated for the missing item as equal to about 50% of the best performing state for the item measure in which Kentucky's data is missing. And that's not a bad way of doing it, but there are other ways and arguably more rigorous ways of imputing data. And the way that we're doing it this time is to use multiple regression analysis, which is a slightly more sophisticated way of doing it, taking into account, and it's missing data are not a huge problem with the index. There were about a third of the item measures have missing data, but in most cases there were only a couple of states So even though it was maybe a third of the measures, for most states, it was only 1 or 2 states where the data were missing. And so what we're doing is that we're using regression to calculate or estimate or predict a value for most of that, of the missing items. But we have a whole nother category of missing data from the labs, and we're still working on trying to acquire updated data for that. And so as a placeholder, we didn't use regression, or we're not using regression for the APHL data. We had existing data for the 2014 index. We have data for most of the updated data for most of the states, and for those states that we do not have updated APHL data, we are just carrying forward the APHL data from the 2014 index. It's not ideal, but it's arguably better to carry forward the previous data than to try to develop a regression model what variables are we using to predict, what are we putting on the right-hand side of the equation here to try to estimate the missing variables value. Well, first of all, we're including all the other measures in the domain. As you know, as I indicated, some of these subdomains only have a couple of measures in them, so we decided to use all the measures within a domain, and then include, in addition to that, some geographic identifiers. There are 9 climate regions in the United States and the continental United States, and so we're including those. Land area, total land area, the percent of a population that is urban in each of the states, and then a series of socioeconomic demographic measures that capture the age distribution, the percent of youth population under 18, the percent of population over 65, and educational attainment with a focus on BA and above, the total population, and personal income, and estimated the values then by creating a statistical model, and then we looked at all of those in comparison to the data that we already had to see if they made sense. And I can tell you that we were really happy with the way that this turned out. We think that this is a very, very strong approach, and we feel very good about it. Now, these numbers, these estimated numbers, are only being used, such as the case was now on the 2014 index on the website, only being used to calculate index values. We're not presenting these estimated values. So, there's not going to be a case where a state's going to, look at their item measure data on the website and say, well, where does that come from? Because it'll show missing data. But we need something there to calculate subdomain, domain, and overall state scores. And so that's why we impute the data. Any questions about the imputation? Great. Okay. Confidence intervals. So what we're doing is that we're using something called a frequentist approach And actually, this is Glenn's bailiwick. Glenn, you mind if I turn this over to you?
Sure, we can do that. So again, as I think many of you who have been with us on these on our analytic methodology calls over the past year know that one of the goals for this next release of the index is to be able to offer users some more specific guidance about the meaning of the numbers, the numeric results that are part of the index. In particular, what differences in numbers might we consider to be meaningfully different. If we're comparing numbers, scores, if you will, across domains or subdomains, when likely to be, when is that state likely to be meaningfully above or below that national average? And the way we do that from a measurement standpoint commonly is with confidence intervals. So that's again the rationale for doing this. There are, as many of you know who are work in measurement and statistics, there are a number of ways of constructing confidence intervals, particularly in an application like this, where we're trying to construct confidence intervals around measures that are composites of a large number of other individual items. And those individual items are measured with uncertainty. Those individual items have measurement error in them, either because of sampling error, because they're coming off of samples, as are some of our measures that are coming off of, census or American, the current population survey or the American Community Survey or other large sample surveys, Burfus and others, or because there's other sources of measurement error in the data. And when you create composite measures, when you roll up a large numbers of individual measures into composites, and you want to reflect the uncertainty in that measures, you need to find a way of capturing and being true to the underlying uncertainty that is embedded in each of those individual measures that you're rolling up into a composite. And so essentially that's our challenge with constructing confidence intervals around these measures. And it gets pretty complex when you think about the index structure. A large number of measures, individual measures, coming into these composite measures that we're constructing at the domain and the subdomain and then at the overall index level. What we're, after, again, looking at what's possible both computationally and what's possible from a data availability standpoint, what we're proposing to do and what we've tested right now for release with this next version with the index is using kind of a standard way of constructing confidence intervals based on kind of standard frequentist statistics. And this is what most of you are familiar with if you're looking at confidence intervals that are being reported, in literature that are constructed off of regression models or other similar, standard types of frequentist statistics based on t-tests or z-tests or chi-square tests. These are the kinds of confidence intervals you're used to seeing, frequentist confidence intervals based on an estimated standard error, and then putting a confidence interval that's plus or minus 1.96 times the standard error. That gives you a 95% confidence interval. That's a frequentist approach to constructing the confidence interval. It's computationally easier to implement, quite frankly, and we need less information. We can construct those confidence intervals with less information, particularly less information about the underlying uncertainty in the individual items that are making up our composites. So that's what we're proposing to do with this next release of the index is construct confidence intervals using that standard frequentist approach of confidence intervals based on a standard error that's calculated, based off of the the items that are being aggregated. And in particular, what that means is that we're constructing confidence intervals only for our national estimates. So we're estimating the national average index values, then when we're estimating those or constructing those national average estimates at the domain and subdomain levels, it's those measures, those national measures, where we'll be constructing the confidence intervals, and then we'll be able to tell, use those intervals to be able to say something about the changes in those measures over time, whether we're seeing statistically significant changes in those measures over time, and also whether, as individual state measures are compared to the national average, those confidence intervals will be used to help us understand which states are significantly above or below the national average. That's the approach that that we're using at this stage, and primarily because for a fairly large number of measures, we don't have good information about the underlying measurement error at the item level, and so we actually don't need that information to construct standard frequentist types of confidence intervals based on our national estimates of the of the mean and the standard error of that mean. So again, with these kinds of confidence intervals, again, we'll be able to use them in the index again to profile the nature and the meaningfulness of changes that we see over time at a national level, changes in index results over time. Talk about which of those changes are likely to be significant or not, based on the confidence interval. And then again, secondly, we'll be able to use those confidence intervals to compare, to support comparisons of, again, comparisons across domains and subdomains to say this domain scores significantly higher than that domain based on these confidence intervals. And then also to support comparisons between national results and state results. So so these confidence intervals could be useful if an individual state wants to say, hey, are we doing significantly better or worse than average in overall or in a particular domain? These confidence intervals are designed specifically to support those kinds of comparisons and those kinds of interpretations. What these frequentist intervals won't let us do, and what we still kind of have some work underway to bring into fruition, is they won't let us compute confidence intervals for individual items or for individual states, state results. And again, because those confidence intervals constructed at a finer level of aggregation at the individual state level requires us to have more information about measurement uncertainty at the individual item level. And that's just information that we don't yet have available for all of the measures in the index. There are some ways, some approaches to eventually get there, but we don't anticipate being able to construct confidence intervals at the individual state level, at least in time for this next release of the index next month. The approach, ultimately we think we are going to be able to get there using what's called a Bayesian method of constructing confidence intervals that is basically allows us some additional computational power for estimating that measurement error at an individual item level and aggregating that up within a state to construct state level confidence intervals. So that's essentially where we're ending up. One other point on this slide, we're proposing to use in terms of how results are interpreted and displayed in this next release of the index. For the U.S. confidence intervals, we're proposing to use a confidence interval threshold at the 90% level, which is a little looser than what you're probably used to seeing as you're reading confidence intervals that are published in scientific papers. Our conventional scientific threshold for showing measurement uncertainty is using that 95% confidence interval. We're proposing to use a 90% interval at this stage, just to be a little more conservative in these results, and partly, that our desire to be more conservative is, first of all, this is the first time we'll be, incorporating confidence intervals into the results and into the interpretation of results. And so being a bit more conservative, I think, is a good thing, just from a communication standpoint, and also recognizing that, again, we're measuring preparedness at a state level. So we've got a relatively small sample size here, 50 states that are measured at 3 points in time at this stage. And so when you're thinking about issues of statistical power, the power to detect meaningful differences across domains or over time, with an N of 50, that's still fairly limited. And so that's another reason, I think, to use a more conservative threshold for what we're going to be labeling as kind of a meaningful difference. And again, for those of you who are familiar with the prior to version of the index, this confidence interval will essentially take the place of what used to be kind of a rule of thumb that was communicated with the prior version of the index, this kind of 10% rule, that was kind of an expert judgment on the part of the index developers, saying, any difference in a score that's less than 10%, that's probably not meaningful. That was kind of the guidance that was given in prior versions of the index. What we're doing with this confidence intervals is trying to be just a little bit more clear, a little bit more specific, and a little bit more kind of data-driven in how we give guidance about what's a meaningful difference in numbers. So that's what we will be able to do with this kind of frequentist approach to traditional kind of keep it simple approach and use these more traditional confidence intervals with a 90% threshold.
Glenn, this is Tom. Thanks for that explanation. That was very helpful. Visually speaking, how will they be just seen as normal confidence intervals? Is there a different way to display them on the website? And a second question is, how wide are the intervals at this point?
Good question. So we were very interested in that. Your second question is how wide are we talking about? Are these intervals going to be so wide that they're really not going to be useful? In terms of offering guidance about what the numbers mean. And what we've constructed so far are just intervals based on the preliminary data. And as you know, Tom, and as Mike referenced, we're still waiting for some hopefully updated data from some of our APHL measurement sources. So we don't have final data and final intervals, but the intervals we've constructed with the data in hand right now suggest that these are reasonably sized intervals. That there are again, when they're applied at the overall level or at the level of a domain or a subdomain, that we're able to still they're useful for helping us to identify, again, differences across domains and subdomains, and also differences between state and when we're comparing state scores to national scores. So they appear to be useful. They're not so large that that we're not able to kind of detect any differences. And also with regard to comparing the results over time, those intervals are small enough to be useful. And in terms of how we would display them, again, I think at this stage we're planning to display them only when we're showcasing national results, because that's really where we're estimating the intervals only for the national results. And so and then we're still looking at options for how we actually visually display that, and working with the website developers on some of those options. But I think kind of I think visually how we traditionally do this is, again, showing that region of confidence in some kind of a gray line or gray area bar, around the actual point estimates, so that you're visually kind of seeing the plus or minus issues in terms of the area of uncertainty around the point estimates. And so I think that's those are some of the visual options that that we're looking at this stage.
Would you mind you said this already, but the 3 different time periods, do you mean the 3 different years of the index?
Yes. Yeah.
Okay. And so how do you display that? Or how does that work?
So, for example, if we're plotting measures over 3 time periods, and you've got envision kind of a line graph with three time points. Rather than just having those 3 time points in one line going through those 3 points, you'd actually have an upper and a lower line, and typically that would be shaded, above and below that line, so you could actually see that region of confidence around the 3 points. And that region of confidence can get smaller or larger just depending on the underlying measurement error at those 3 points in time.
Do you think that the confidence intervals from the first 2 years of the index are going to be substantially different for the same domains or points as compared to this year's index, or will they be relatively similar?
Yeah, the size of the intervals actually is pretty similar and not
Okay.
dramatically different across the 3 time points in terms of how large the intervals are. Whether those intervals actually overlap with each other over time, meaning whether we can say there's a significant increase or decrease over time, I think just depends. I think there are at least for some domains and subdomains in the preliminary data that we've run at this stage, we are already able to see some statistically significant increases, mostly in preparedness across that 3-year period. With the preliminary data we're looking at right now, when we're looking just at the aggregate scores, while we see an overall trend toward increasing levels of preparedness at the national level, using that overall aggregate index, those 3 confidence intervals are, at this stage with our preliminary data, overlapping. So we can't say, if the preliminary results hold, likely the story would be there's a trend toward increasing levels of preparedness overall, not at a level that would reach statistical significance yet. But although when we look at scores at a finer level at a domain or subdomain, there are certainly some domains and subdomains where we do see some statistically significant increases in preparedness scores over time. That's all based on just our preliminary data at this stage, and that some of that will shift as we get in these last few measures, APHL measures.
And just to add to what Glenn said, Tom, and to address your question, so on this slide, the first bullet here, which you can see, any given state for any of the 3 years will be take on one of 3 values. Either it will be above, it'll be below, or the same as, that is to say, within the confidence interval of the U.S. And so, another option is to have a map of the United States of showing all the states, and as you go between years, you can see different colors, one of 3 colors, depending upon whether, let's say, Kentucky is above, below, or the same as the U.S. Okay, so now let me slide the scale from 2013 index to the 2014 index. And I've gone from the same as the U.S. To above the U.S. And I don't know that this is the case for Kentucky. I'm just using this as a hypothetical example. And now I slide up from 2014, the 2014 index to the upcoming index, and I see that it's changed yet again, right? As all the colors on the map change. So there are more intuitive ways yet even to display this, what under the hood is a very complex process that Glenn described, but yet you can present it in a very kind of simple, straightforward way. And there, as you know too, I think you've been in some of these conversations, there will be FAQ, methodological FAQs and toolkits that go into more detail about what's going on under the hood. The last slide is, well, second to last slide is the final agenda bullet is a in-person meeting that we'd like to have with the model design and analytic methodology members at RAND in Santa Monica. Chris Nelson, the chair of the model design group, has very graciously secured meeting space for us at the RAND Santa Monica headquarters, and the date that we're looking at is Wednesday, July 27th. So please put that on your calendar, and you'll be hearing more about that. We are approaching the 1 hour mark for our meeting. Are there any quick questions that we can address? Thank you all so much. If you think of anything, you know where to reach us. This slide gives that information. And then next week, we have our model design work group meeting, and we'll be talking really about some different aspects of the progress that we've made on the index then. And that's Tuesday at 1 p.m. Eastern Time. Same kind of deal, virtual meeting. The information I'll be sending out probably Monday. Thank you.
Thanks, everybody. Thanks, Mike.
Thank you.